So here is another question on projectile motion with angular projection. So it is given that a boy stands at a distance of 39.2 meter from a building and throws a ball which just passes through a window in that building, and that window is 19.6 meters above the ground. Calculate the velocity of projection of the ball. So let us try to understand this whole situation. So here we have a building. That building has a window. Okay, that window is 19.6 meters above the ground level. Okay, a boy stands at a distance of 39.2 meters from the building. He throws a ball, okay, with a certain initial velocity which is asked, and also a certain angle with respect to the horizontal, okay, this theta. So the ball undergoes this kind of a trajectory. Okay, actually this whole thing starts here. Let's bring it a little bit below. Okay, here. Okay, so the ball undergoes this kind of a trajectory. It passes through the window, okay, and it reaches this position here. So indirectly in the question we have been given two important information. The ball just passes through the window in that building. It means that when it just passed through the window, the ball was at the maximum height. Okay, it was at the maximum height, which is 19.6 meters. So this 19.6 meters is nothing but H max, because it has been mentioned specifically that the ball just passed through the window. So it was at the maximum height when it did that. Then when it just passed through the window on that building, so at that point the distance from the building, that is r by 2. This is r by 2. At the point of maximum height, if we draw a dotted line downwards, that point from the starting point will be r by 2, half of the horizontal range. So r by 2 is equal to 39.2 meters. That implies the horizontal range is equal to 2 into 39.2, which is equal to 78.4 meters. Okay, so we have two important information with us. H max 19.6 meters, horizontal range 78.4 meters. Okay, now if you remember, we came at an important formula, relationship between maximum height and horizontal range, that is H max by R is equal to 1 by 4 tan theta. H max by R is equal to 1 by 4 tan theta. That implies tan theta is equal to 4 H max by R, which is equal to 4 into 19.6 by 78.4. So it is coming 1, because this is 4 and this becomes 1. Okay, that. So tan theta is equal to 1. That implies theta will be equal to tan inverse of 1, which is equal to 45 degree. So the angle of projection is equal to 45 degree. This we have calculated that. Now we can use any of the formulas, be it for horizontal range or maximum height, to determine the initial velocity of projection. So let's go with horizontal range first. Okay, we know horizontal range is equal to u square sine 2 theta by g. That implies 78.4 is equal to u square sine 2 into 45 degree, that is equal to 90 degree, sine 90 degree by 9.8. That implies u square is equal to 78.4 into 9.8. That implies sine 90 degree is 1. That implies u is equal to root over of 78.4 to 9.8. So it is coming around 27.718. So rounding it off, 27.72 meter per second. That is the initial projection velocity. Now you can use the other approach also for maximum height, going through maximum height that way. So the formula for maximum height, that is equal to u square sine square theta by 2g. U square sine square theta by 2g. So here maximum height is equal to 19.6 is equal to u square sine theta, that is sine 45 degree, that is equal to 1 by root 2 whole square by 2 into 9.8. Okay, 2 into 9.8. So that implies 19.6 is equal to u square into 1 by 2 by 2 into 9.8. U square equal to 19.6 into 2 to 9.8 by 0.5, or we can multiply it here, okay, into 2. So cut this. There is no need for this. Okay, simply I have taken this 1 by 2 and multiplied in the numerator. So we have the same thing, that is 78.4 into 9.8. So we'll have 19.6 into 4 is 78.4. So same result we'll be getting. So that implies u is equal to root over of this whole expression. U will be root over of this whole expression, and it will be the same result, 27.72 meter per second. Okay, because 19.6 is into 2 into 2, that is 19.6 into 4 is equal to 78.4. This. So 78.4 into 9.8 will be the same result, 27.72 meter per second. So either way you will get the same result, 27.72 meter per second. Okay, so here this relationship which I told you, it came in handy. H max by r, that is maximum height by range, is equal to 1 by 4 tan theta, where theta is the angle of projection with respect to the horizontal. Okay. So here is another question on projectile motion with angular projection. It is given that find the angle of projection for which the horizontal range and the maximum height are equal. Okay, so here the situation is that for the angular projection, okay, with this angle, here the maximum height and the range, they are equal. So here, if you recall the important relationship between maximum height and horizontal range, h max by r is equal to 1 by 4 tan theta. Okay, so here according to this question, h max, that is maximum height, is equal to horizontal range r. That implies this ratio will be equal to 1. That implies 1 by 4 tan theta is equal to 1. That implies tan theta is equal to 4. That implies theta is equal to tan inverse of 4, which is equal to how much? It is coming around 75.963 degrees. 75.963 degrees. This is the angle. Now, if you are not able to recall this formula and you remember the formula for horizontal range and maximum height, then you can proceed also this way. So here the formula for horizontal range, which is equal to u square sine 2 theta by g. This formula for maximum height is equal to u square sine square theta by 2g. Now according to the question, r is equal to h max. H max is equal to r. That implies u square sine 2 theta by g is equal to u square sine square theta by 2g. So we can write it as u square into 2 sine theta into cos theta. Sine 2 theta we are writing as 2 sine theta into cos theta by g is equal to u square sine theta into sine theta by 2g. Both sides u square it will get cancelled. Okay, sine theta that will get cancelled. G that will get cancelled. That implies sine theta, okay, by cos theta. This cos theta goes to the denominator here. So sine theta by cos theta is equal to this 2, it goes and gets multiplied here. Okay, this 2, it goes and gets multiplied here. Sine theta by cos theta is equal to 4. That implies tan theta is equal to 4. That implies theta equal to tan inverse of 4. And we have the same result, 75.963 degrees, this much. So either way you will get the same result. Okay, so if you remember this formula, h max by r is equal to 1 by 4 tan theta, you will be able to solve it in a matter of a few seconds. In case you forget it and you remember this, it will take a little bit longer time, but you will arrive at the same result. Okay,